Now, for convenience of solving this numerical, let's put the given data in a two-dimensional Cartesian coordinate system, that is XY coordinate system. Here is the interpretation of the data in a two-dimensional Cartesian coordinate system, that is XY coordinate system. Now, the particle is initially having a velocity of 2 meters per second. Of course, let's take that along x-axis. So, the initial velocity vector of the particle is represented by 2 cap meter per second. And it is subjected to an acceleration of 2 meter per second square, making an angle 60 degrees with the initial direction. Now, this acceleration, which is acting at an angle 60 degrees with the initial velocity, will have two components. And one component will be in the initial direction, that is along x-axis, that is a cos 60 degrees. And there will be another component now which is perpendicular to the initial direction. Initially there is no velocity in the perpendicular direction, but because of this acceleration component, that velocity keeps on increasing. Perpendicular component also increasing because of this acceleration component ay bar, that is a sin 60 degrees component. And thereby, after a time of say t equal to 1 second, the particle is now having an accelerated velocity because of acceleration, increased velocity component along x-axis and increased velocity component along y-axis because of the acceleration. Therefore, we have to calculate the velocity vectors along x-axis after 1 second and along y-axis after 1 second. And these two perpendicular components will have a resultant value of velocity that we have to calculate. So let's go ahead with the solution for this. Now it's given that initial velocity along x-axis as 2 cap meter per second and initial velocity along y-axis, that is uy bar, is 0 bar. There is no velocity along the perpendicular. And the acceleration, when we resolve it into two components, ax bar, the acceleration component acting along the x-axis, will be a cos 60 degrees I cap, and this is equal to the value of a is 2 into cos 60 is half into I cap. So this all it is 1 into I cap. Okay, this is all in meter per second square, and velocity is in meter per second, acceleration is meter per second square. So the acceleration component along the x-axis is I cap meter per second square. The acceleration vector along y-axis, the component along y-axis, is a sin 60 degrees j cap, and this is equal to 2 into sin 60 root 3 by 2 j cap, and this is equal to root 3 j cap meter per second square. Now after t is equal to 1 second, after an interval of 1 second, Vx bar, the velocity vector along x-axis, equal to ux bar plus ax bar into t, and this is equal to, what is ux bar is 2I cap plus ax bar is 1I cap, so 1I cap into the time run as given is 1 second, and all that is equal to 3I cap meter per second. So the velocity component along x-axis 3I cap after 1 second. What about Vy bar, velocity component along y-axis after 1 second? Again same way, uy bar plus ay bar into t, and this is uy bar is 0 bar, there is no velocity, plus ay bar we got as root 3 j cap. The time run is again 1 second, and this is root 3 j cap meter per second. Therefore, the velocity vector of the particle after t equal to 1 second is Vx bar plus Vy bar, and which is equal to 3 cap plus root 3 j cap meter per second. And it is asked for the magnitude of this velocity. Therefore, magnitude of V bar after t equal to 1 second is square root of 3 square plus root 3 whole square, and this is equal to root of 9 plus 3 root 12 meter per second. And this further in the given options, it is given as 2 root 3, root of 4 into 3, so 2 root 3 meter per second, and hence option 2 is our correct answer. See here, it's a very interesting question, a standard model question in entrance point of view. Not that a direct formula substitution. It's not a case of formula substitution. Some analytical approach is required to solve such type of questions. Here, the acceleration has to be resolved into components, and that acceleration is to be applied along the initial direction and along perpendicular direction to it, and thereby the velocity is increasing in the initial direction as well as in perpendicular direction, and those two components are added, and final velocity vector we obtained, and the magnitude of that was calculated.